Now we're going to continue with 12.4 college algebra. Find the inverse of a matrix, but we're not going to do it as I guess they've done it in the textbook. So listen carefully. We're going to use our calculator to help us. First of all, what is an inverse of a matrix? Well, let's go back to what is the additive inverse. Oh boy, is that really horrible. What is the additive inverse of a real number? Well, whatever you add to it, you get the identity, which is 0. So what is the additive inverse? That's a negative a. Whatever a is, take the opposite. What is the multiplicative inverse? Of any real number? Well, whatever you do when you multiply, you get the identity 1. So what do you multiply a by to get 1? 1 over a. So they call this the inverse. They call this an inverse. What is a matrix inverse? And it's really matrix multiplication. Well, whatever you multiply that matrix by, you have to get the identity matrix. This is the identity for addition. This is the identity for multiplication. The identity for any matrix is 1s down the main diagonal, however big it is, and 0s every place else. So it's going to be a square matrix. It's only a square matrix for the identity. 1s down the main diagonal. And so we're looking for that matrix that when you multiply, this is the inverse. It's like 1 over a, but really this should be read as the inverse of a, not 1 over a. It's not the same. That'll give us this identity. So let me grab my calculator, clear out this screen. Let's go into the matrix, second matrix, go over and edit. Let's do a 2 by 2, I guess. Matrix A, a 2 by 2. And if we put in the 1, 2, 3, and 4, so we have 1, 2, 3, 4. If A is 1, 2, 3, 4, we want to know what is the inverse to get 1, 0, 0, 1. That's the identity for a 2 by 2. This is a 2 by 2. This will also be a 2 by 2, but we'll find that it's got some fractions in there. So this is 1, 2, 3, 4. Let's get out. Second quit. Now, what's nice with the calculator is you go and get that matrix, the name A, and you can use this x to the negative 1 to find the inverse. It knows, because this is a matrix, it's not just 1 over a. It knows it's special. It's negative 2, 1, 1.5, and negative 0.5. Now you can change that to fractions if you go to math. And this first thing under the math is frac. And we'll change that answer to fractions. So it's really negative 2, positive 1, 3 halves, and a negative 1 half. That is the identity. Why? Well, let's store that. First of all, you can store it into another matrix, stow, and I'm going to put that in second matrix. Let's put it in matrix B. So we're going to store our answer into B. So now, if you go in, second matrix, A is the 1, 2, 3, 4. Second matrix, B is the inverse, negative 2, 1, 3 halves, negative 1 half. And if we multiply those together, second matrix A times second matrix B, we should get 1, 0, 0, 1. So these inverses are not as nice or easy as these, finding the opposite for addition, find the reciprocal for multiplication. This is really sort of a crazy matrix for this stuff. There are ways to find it, but for us in this class, we're just going to use the calculator and use that inverse. So if we do and take B here, matrix B, and find the inverse for that, what do you suppose it is? Well, it's our one we started with, 1, 2, 3, 4. So now the order can be either way. The commutative property doesn't hold normally, all the time at least, for matrix multiplication, but it does if you've got inverses. So that's finding the inverse of a matrix. Now let's suppose we want to solve a matrix. If we have an equation, let's say a simple equation, right? 2x equals 4. We know if we multiply by the reciprocal of 2, 1/2. And if we multiply the right side by that 1/2, that these will cancel and we get x equals 2. Now it's important to recognize that because multiplication in the real numbers is commutative, it doesn't matter if I multiply on the right or the left with that 1/2. But technically, I guess, if I multiply on the left side of the equation, I should multiply on the left on the right side of the equation. Still get the same answer. But let's do this with a matrix equation. Let's start out with a system, x plus 2z equals 6. That means we have an x and a y and a z. And a negative x plus 2y plus 3z equals negative 5. And x minus y equals 6. So we have three sort of matrices here. We've got the coefficients, the 1, negative 1, and 1 for the x. For the y's, we don't have any y on the first one, so it's 0, a 2, and a negative 1 for the next two. The z column, we've got a 2 here, a 3, but no z in this third one, so it's 0. That is the coefficient matrix. Now this is a 3 by 3. We need this to be a 3 by for us to multiply. And this is the variable matrix, x, y, and z. And that equals, this equals on the other side, the 6, the negative 5, and the 6, which is this is a 3 by 1. This will be a 3 by 1 because they are conformable for matrix multiplication, and the answer is a 3 by 1. Now, this also should make sense because 1x, because when you multiply, you go across the row down the column. 1x, 0y, 2z equals 6. 1x, 0y, 2z equals 6. So you can write this matrix equation. How do we figure this thing out? Well, we take the inverse of this and multiply on the left. We can also multiply on the left for this. Let's call this A. This matrix A. This is our X matrix. And we'll call this B just so that we can have something over here. Okay. But we need, really, A inverse times the A times this X. And that equals, and on the left is important for matrices, times the B. And here's where we get our answer. This will just be the identity. So it'll be X, Y, and Z equals this stuff. So let's put that in. First of all, we need to clear this out. Get into the matrix. Edit. Or use A because that's a good one to use. This is a 3 by 3. It is 1, 0, 2, negative 1, 2, 3, 1, negative 1, 0. That's what A is. Now, to edit the next one, you can't stay in there. You got to get out and then get back in and go over to edit. We're going to edit B now. B is not, we're not going to put any of this X, Y, Z in. That's going to be our answer. B is going to be a 3 by 1 matrix. And that's going to hold 6, negative 5, and 6. So now we've got those two. Our final answer will be the X, Y, Z equals, because we're going to take the inverse of A. Let's get out to see. 6, negative 5, 6. Okay. We're going to take A, second matrix, A, inverse, times B, second matrix, B. That's that A inverse times B. And this gives us the answers 4, negative 2, and 1. So X is 4, Y is negative 2, Z is 1. And what I want you to get out of this is matrix multiplication, matrix algebra is really just like normal algebra, except you're using matrices. Remember, multiplication is not commutative, so you got to be a little careful. But it's sort of cool, too. Another way of solving a system of equations.